Hey everyone, welcome back to the channel, your go-to place for tech insights, real-world architecture, and interview prep. In today's video, we're diving into one of the core foundations of Apache Kafka, the main components of Kafka. Whether you're learning Kafka from scratch or gearing up for an interview, knowing the components and how they work together is absolutely essential. So, grab your coffee and let's get streaming. Section 1. The Big Picture. Before we break down the components, let's get a quick overview of how Kafka works. Think of Kafka as a real-time data pipeline. It's designed to move data efficiently from point A to point B, but at scale, reliably, and in real time. This pipeline is built using a set of key building blocks, and understanding them will help you reason about any Kafka-based architecture, whether you're designing a simple system or working with a large-scale microservices setup. So here are the 5 main components of Kafka. 1. Producers. 2. Consumers. 3. Topics. 4. Brokers. 5. ZooKeeper or KRaft, the new metadata layer. Let's break each one down. Kafka Producer. First up, the producer. A Kafka producer is any service or application that sends data into Kafka. Imagine a shopping website. Every time a user clicks Buy Now, the checkout service can send an event, like a purchase-made message, to Kafka. That service is the producer. Features of a producer. It decides which topic to send data to. It can choose which partition within the topic. It ensures delivery guarantees, like at least once or exactly once semantics. Producers can send thousands or millions of messages per second. Kafka is built to handle that kind of scale. Kafka Consumer next is the consumer, the component that reads data from Kafka. Just like a subscriber in a publish-subscribe model, a consumer subscribes to topics and consumes messages in real time. Let's go back to our shopping app example. A billing service might consume the same purchase-made messages and create invoices. A warehouse service might use those same messages to initiate packing. Kafka's decoupled architecture means you can have multiple independent consumers reading the same data stream, without interfering with each other. Consumers can work in groups, called consumer groups, to share the load. More on that in a future video. Kafka Topic. Now let's talk about topics, the heart of Kafka. A topic is like a category or channel where data lives. You don't send messages to Kafka directly, you send them to topics. Example, you could have topics like user signups, payment events, order confirmations. Data inside a topic is stored in partitions, and that's where Kafka gets its power to scale. Key points. A topic can have multiple partitions. Messages within a partition are ordered. Partitions are distributed across Kafka brokers. We'll cover partitions and offsets in detail in another episode. Kafka Broker. A broker is a Kafka server, a node in the Kafka cluster that stores data and serves client requests. Think of it like a post office. It receives messages from producers. It stores them in the right topic and partition. It delivers messages to consumers when they request it. Kafka is designed to be distributed, so you can have multiple brokers, and each one takes care of a part of the total workload. For example, if you have 3 brokers and 6 partitions in a topic, Kafka will balance those partitions across the brokers. If one broker goes down, Kafka's replication mechanism ensures your data is still available on another broker. ZooKeeper or KRaft. Until recently, Kafka used Apache ZooKeeper to manage cluster metadata, broker coordination, leader elections for partitions. But now, enter KRaft Mode, KafkaRaft Metadata Mode. KRaft allows Kafka to run without ZooKeeper, making it simpler, faster, and easier to manage. Kafka now handles its own metadata internally, which reduces complexity and improves startup times and scalability. If you're working with newer Kafka versions, 2.8 plus, you'll likely be using KRaft Mode instead of ZooKeeper. Real-life analogy. Let's tie this together with a real-world analogy. Imagine Kafka as an airport. Producers are airlines dropping off cargo. Topics are terminals. Partitions are gates. Brokers are airport staff managing the loading and unloading.
Consumers are delivery trucks picking up packages. And ZooKeeper or KRaft is the control tower managing coordination, all working together to keep data, or cargo, moving smoothly. And there you have it, the main components of Apache Kafka explained in plain English. If this helped clarify things, smash that like button, drop a comment with your doubts, subscribe for more deep dives into Kafka and other tech topics. Coming up next, how Kafka achieves fault tolerance and high availability. Deep dive into Kafka topics and partitions. Thanks for watching, and as always, keep learning, keep building, and keep streaming with Kafka.